All right, welcome to Lab 10. I promised this one. I showed you a little bit about it before, and now we're ready to do it together. All right, so square roots. You're going to make a square root calculating function from scratch without using anything else in the libraries. That's going to be really cool. It's going to be doing that binary search style repeated guessing process. All right, so this is a really fun one. It is a little weird and hard to wrap your mind around at first, but it will be very satisfying, just like the graphing calculator program lab. Once you get it working. Okay, so yeah, get the code. Here's what it all looks like, and you're going to be working on the square root library. Okay, so there's the first one is an approx equal function. You're going to want to use that, and then the square root function is going to actually calculate the square root. Okay, so let's look at both of those files. So square root.h, there's the header file for your library. And yeah, you're going to be writing these two functions. Approx equal should return what true if two numbers are very close to each other, approximately equal. So you'll have to do like absolute value and less than and subtraction and all that, like I was showing you before. So check if two doubles are very close. I'll give you a range in just a second. And then here's the square root function that you'll be writing. All right, so this one takes a double, the number that you want the square root of, and it gives you back the square root of that number. It'll find it, always. That's really cool that you're going to be able to program that. All right. So yeah, for approx equal, I want you to return true if the numbers are within this amount of each other, 0.000001 of each other. All right. So do your subtraction and your absolute value and just like make sure it's within that range. Okay. If so, for our purposes, it's good enough. It's accurate to 6 decimal places. All right. And we're going to be using that in the square root function. All right. So right now, these are both stubs. They're completely wrong. Please delete this code and replace it with the right code. So square root is where you're going to be making your repeated guesses. It's going to be a loop, just like binary search. All right. So, all right. Yeah. So approx equal returns true if two doubles are very close to each other, and false otherwise, just like they're very close. And then for square root itself, you're going to be doing that repeated guessing process to see where the square root really is. You're going to start your range of your guesses, like, all right, the answer for the square root is somewhere between here and here. And you're going to keep on guessing in the middle of your range and updating your guess. Okay, so yeah, you're because the graph of square root that we're trying to create or trying to calculate square roots, because the real graph of square roots is increasing, you're never going to miss the real answer. And so this is why the binary search process is going to work. And yeah, so maybe go back to the lecture where I was explaining this before, because now I'm going to go on from there, assuming that you already understood that stuff. So, okay. Yeah, what's going to happen is, like, let's say that somebody was asking you for the square root of 5. You start your range, right, your low and your high, between 0 and 5. Like, whatever the square root of 5 is, I'm not sure what it is, but I know it's between 0 and 5, right? That's your starting range, all right? Somewhere there. And then you start guessing in the middle, like, try 2.5. You check, was that close enough with your approx equal? And when you find that it wasn't, right, you'll just, like, multiply things and see if it was between the right values. You'll notice that, okay, that was maybe a little too big. I'll change my high index or something, all right? So at the very beginning, you start out your search space and make it so that it always contains the actual square root somewhere. So your search space should always have a lower limit of 0. You can have a smaller than 0 square root. And your upper limit, just make sure it contains the square root. So a good way to do it would be like make it be the max of 1 in the number, or even like x plus 1 would work as well. Because if your square root, if you're asked to take the square root of a number that was smaller than 1, like 0.25 or something, it's bigger, isn't it? You remember that? So, do you remember that? Import math. So, square root of 0.25 is 0.5. It got bigger. So you can't just say like, oh yeah, let me start my search space between 0 and the number x I'm trying to find the square root of, because it might not contain the actual square root. So you can do the max function, or just like add 1. That would also work. Just like make sure your range is somewhere. All right, it has the actual square root. And then you're going to keep on making guesses. You're going to calculate the midpoint of your search space. It's like 2.5 for this example. And then, because you don't have access to square root, because you're writing square root, you can square, right? You can square your guess and see if it's close enough to the original number. All right, that's what we were talking about in class before. So go back to that if you need a refresher, but that's what you want. You just like keep on calculating the midpoint and checking and seeing if it's a good enough guess with approx equal. Otherwise, change one of your ranges, like either high was too high or low was too low, set it to the midpoint, and it'll work out. All right, so that's what you're going to be doing, that repeated guessing process until your answer is close enough with approx equal to 6 decimal places of the actual square root. Okay, definitely start early. Yell at me if you have questions, but this is the idea, right? So here's how your program should think. I've made a very long table here to tell you exactly how your program should think when it's calculating a square root. All right, so this is what you should check for if you want to start printing out stuff. You do not have to print out any of this stuff. This is just for your help, all right, to help you. So, all right, let's say that someone called us with x equal to 9. We're trying to calculate the square root of 9 right now. We know that the answer is 3, but let me show you how your code should notice that and discover it, okay? So here's how it should set its variables. It's low and it's high, for example. So at the start of time, we're asked for the square root of 9. We're not sure where it is, but we know that it's going to be between 0 and 9 itself, okay? 0 and 9, that's my lower limit and my upper limit. Does that make sense? Wherever the square root is, it's between there and there. All right, so let's try our guessing. We're going to guess in the middle and see if that's a good enough guess. All right, see if that is correct or not. So the midpoint of my lower limit and upper limit is 4.5, right? It's the average of 0 and 9. Let me zoom in some more so you can see all this. Iteration number 1. Average of your lower limit and upper limit is 4.5, and you then go and check, like, hey, was 4.5 a good enough guess for the square root of 9? You don't have square root at your fingertips. You're trying to calculate the square root, right? That's you. So the only thing you can do to see if this was good enough is to square it, right? Because if you square what was the square root, you should get back to the original 9. So you're going to square 4.5. You can use math and multiplication to do that, right? And then you'll get back something huge, right? Much bigger than the 9 that it should have been. So that means your midpoint was bigger than the real square root. Do you see how you can conclude that? So that's that. So that your guess was too high. So that means your upper limit was way too big. Wherever it was never 9. It wasn't even 4.5. 4.5 was too big. So you use 4.5 as your new upper limit. Do you see that? So your lower limit remains 0 for the next round. It's going to be a loop. And your upper limit becomes the old mid, because that was already too big. All right, so now go guess in the middle of that. You see how that's going to play its game. So now the midpoint of that search space is 2.25. You'll see by squaring that, you'll see if that was close enough to the real square root. Because if you square the square root, it should have been 9, right, for the square root of 9. So you'll square it, you get something 5 point something, then that was too small, right? So that means that your lower limit was too small. 0 was way too small because 2.25 even was too small. So like 2.25 is a better lower limit. Do you see that? So you're cutting off half of the range each time you make a guess and you check it. So now your lower limit should be the old mid, 2.25, and your upper limit stayed the same at 4.5, and you keep trying with that range. You see how you're cutting off half of the numbers as you zoom in. You're zooming in into the number line. And so like the new midpoint is 3.375. You see how it's making its way to the right answer? It's like, all right, squaring that, it's a little too small, or sorry, a little too big. And so that means that the upper limit was too large and mid was a better upper limit. So you'll change that. And so the lower limit stayed the same because of that, and the upper limit becomes the old mid. And then you keep on guessing and checking. So the midpoint of that, this time it was 2.8, and so that when you square it, it was a little too small, so you'll change the lower limit again. And so you'll keep playing this game for a bunch of iterations, right? And eventually, you get to here, right? Eventually, like iteration 24, it's like lower limit's that, upper limit's that. The midpoint is this. The mid squared was a little too small compared to the 9, right? So we're going to guess high. We're going to change our lower limit then to be the old mid, so this is going to become our lower limit. The upper limit remains the same. And then this last time, the midpoint is this. You square it, and you notice that this answer is approximately equal to this many decimal places, good enough to the original 9 that I was asked to take the square root of. So if mid squared is almost 9, that means mid is a good approximation for the square root of 9. And that's what you return. You return mid at that point, and that's it. All right, so eventually, the middle of your search space squared will become approximately equal to the original value, and that's what it means to be the square root. You have now calculated the square root. You can return it. Return your midpoint. Does that make sense? That's really, really cool that it works like that. It really will work. Get that working. Okay, that's what I want. That's what square root should look like. It's going to be a loop until it's approximately equal. Then you can return. Okay. The other thing to watch out for is the square root graph does not have any definition for any negative numbers. You can't take the negative square roots. There's no i's or anything, right? So just throw a runtime error, and you can put anything, any string within the runtime error if x is less than 0. All right. So if somebody wants a negative square root, don't let it happen. Just throw a runtime error, please. All right. And so with that, I've given you some tests. I've given you some tests already. Get those to work first of all. There's a square root test.cpp file that I've made with tests for you. Get that compiled and running. Don't use G++ yourself this time. I've made you a make file. Use the make file. You can say make, just say make, because it'll run this first rule. It's the same as saying make square root test. So it's going to do it as efficiently as possible. We got also a testing library, because why not? We have multiple files. I've already given you the make file. So it's just going to do separate compilation and compile as efficiently as possible all these things, all these files that we're using. All right, so here's the testing files. So I've already given you some. Some tests exist already. I've made a bunch. I've made them inside of a class for fun this time. Why not? Here's the square root of 2, making sure that the answer is right. Square root of 0.5, making sure that's right. And then here's a test that's making sure that if you try to take the square root of a negative number, it's going to throw a runtime error. Okay, so those are my tests. I would like you, once you've got mine working and passing, to please write 4 more. 4 more tests. So you should see passed 3 + 4, 7 times by the time you're ready to turn things in. All right, so just follow my lead and add 4 more tests to like this class and call assert true 4 more times with some weird combination of things. All right, so check edge cases. Maybe like the square root of 0 would be a good test. See if yours does that right. Yeah, so make 4 more tests, please, with whatever you'd like, and just call assert true. Get those to pass. So 7 passed outputs total, and then you're ready to turn it in. All right, so what you have worked on is the square root implementation library stuff, so the .cpp file. You cannot touch the header file, just the CPP file. You'll be tested with the original header file. And then the square root test.cpp file where you implemented your own tests. All right, so those are the 2 files that you're messing with, that you're allowed to mess with, and then those will therefore be the files that you're turning in. All right, so that's, I think, all that I want to say. So you're turning in those guys, and yeah, start early, ask me lots of questions, but I think that's all that I've got. That's your lab 10. It will be very useful to try out 3 and maybe print out these things if you're having errors. You can watch it work and make sure that you're doing the right things, just like this should be doing. Okay, so compare if you need to, and yeah, I think that's all that I've got. I'll see you later.